Hi! If you follow my channel, then you know that I'm a passionate smart home maker and I love all tech things. My goal is to inspire with fresh ideas and to level you up with tech knowledge. But how did I become such a smart home guru and how can you get there as well? I will show you a selection of my projects and guide you to how to become a smart home guru. What are the ingredients for becoming a smart home guru? Well, first and most importantly, you should have the will to automate your house and add convenience to it. You also need some tech enthusiasm. It's definitely helpful to have some basic knowledge in electronics, CAD and software development, but it's not mandatory. You also need to just gain experience by carrying out as many smart home projects as possible. And there's one very important other ingredient that I'll tell you at the end of the video. I want to tell you now how I became such a smart home guru. It all started when we moved into our new house, which was not really prepared to be a smart home. The first thing I wanted to automate were the window shutters. Yes, they were radio controlled, and yes, they even allowed to set a time when they should go down in the evening and a time when they should go up in the morning in the little radio remote control. But as you all know, the sun is going down at a different time every day and it's going up at a different time every day as well. So I had to change the clock in these little radio remote controls every other week. So annoying and definitely not smart at all. The very first attempt on how to solve this was the idea to just open one of my spare radio remotes and just solder some cables to the buttons where you would usually press up and down in order to kind of remote control the remote control with a Raspberry Pi. This actually works well, but it comes with certain drawbacks. And the most annoying one is that for each different window shutter, you had to use a different channel on the radio remote control. And one radio remote control was only able to control 5 of the window shutters. But I had more in my house, so I would actually have to hack a second radio remote control in order to be able to control all the shutters in my house. And one important problem is that you need to switch channels on the remote control in order to address a certain window shutter. First of all, that means the Raspberry Pi needs to memorize the state. That means the Raspberry Pi needs to memorize in which channel the radio remote control is at the moment. And then it needs to switch channels to the channel for the addressed window shutter before it is able to control the window shutter. Let's say I'm currently in state channel 1, but I want to control the window shutter number 4. So I would need to switch the channels from 1 to 2, then from 2 to 3, then from 3 to 4, and then I would be able to move the window shutter up or down. This adds a lot of delay to the process of controlling the window shutters, and it's definitely not a perfect solution. So I realized this is a very nice hack, but it's definitely not a perfect solution, and I think it should be possible to make it better. So I started to kind of reverse engineer the radio signal that's being sent out by the radio remote controller. In the datasheet I figured out that it is a 433 MHz technology that's used by this radio remote controller. I bought a 433 MHz radio receiver and I attached it to a Raspberry Pi via the GPIOs. Then I installed PiScope. That's an app for the Raspberry Pi which allows the Raspberry Pi to work as an oscilloscope. And from there I just recorded the signals that were sent out by the radio remote controller. By doing this, I realized that there is a certain pattern. The first part of the signal was always constant when addressing the same window shutter. The only part that was changing was the second part of the signal, and this changed based upon when I pressed up or down or stop. And then I realized if I address a different shutter, then the first part of the signal is changing and the second part of the signal is constant when I use the same command. So I figured out that the first part of the radio signal must be the address of the window shutter and the second part of the signal must be the command up, down or stop. After having figured that out, I just recorded all the different addresses of all the window shutters in the house and also all the possible commands, which were actually only up, down or stop. With that, I was now able, by attaching now a 433 MHz sender also to the Raspberry Pi, to send out those radio signals by myself. And by doing this, I realized that I was now able to control the window shutters by myself. This worked very well in most cases. In some rare cases it didn't really work out, but I'll tell you more about why this happened later on. Now I was able to control my window shutters via my Raspberry Pi. Very good. But now I needed some kind of handy control device in order to control the window shutters. So I implemented my own Amazon Alexa integration. For doing this, I had to monitor the state of the window shutters from the Raspberry Pi via MQTT to the cloud and store the state of the window shutters there, and then also exchange the state with the Amazon Alexa integration that I had developed myself in the development mode of Amazon Alexa. With that, I was now able to control the shutters via Amazon Alexa with voice commands or also with the Amazon Alexa app. And I even developed my very own smartphone and smartwatch apps. I developed the smartphone app in React Native. This is a cross-platform framework which allows to use apps on the Apple ecosystem as well as on the Android ecosystem. This was important because my wife uses Android and I use Apple, so I was compatible within the family. And I even developed a smartwatch app for my own Apple Watch. This was super cool. On the left side of the screen you can see the smartphone app. On the right side of the screen you can see the smartwatch app. The app does not only allow to control the shutters, but also allows to see the status of some sensors in my garden, as well as the status of my robotic lawnmower. I have to admit that all this happened before I had discovered Home Assistant as an open smart home ecosystem. There was still the issue that the state of the window shutters memorized in the cloud got out of sync as soon as someone in my house used the little classic radio remote control in order to control one of the window shutters. To address this, I used an RTLSDR device, which is kind of a radio receiver with kind of a longer reach. And with that, I was able to record the signals that were sent out by the little radio remote control and use that to update also the state in the cloud, and with that the state in the cloud was always up to date. In the video linked above you can see the actual result. But remember that I told you before that in most cases the solution sending out the commands with the Raspberry Pi worked flawlessly, but in some rare cases it just didn't work. After further digging into this issue I realized that this had to do with the operating system running on the Raspberry Pi. It's Raspbian. It's a Linux derivative. And the problem with Linux is that it's not a real-time operating system. That means that my Python script, which was creating the radio signals to control the window shutters, had not always the highest priority in the operating system. And that means that it was sometimes interrupted by an operating system process, even though I had given this Python script the highest priority possible. When the Python script was interrupted by another process while sending out the radio signal, the radio signal stayed in high or low for a longer time than usual before it continued to go up or down. And that meant that the window shutter just didn't recognize the signal anymore and didn't react. The only way to get around this was switching to a real-time environment, which was in my case an ESP32 environment. There I could really control all the processes running, and I could ensure that the signal was always sent out perfectly. This was my very first project working on a smart home, and I really enjoyed this project so much that I got really addicted to all the smart home stuff, and I was playing around with everything else afterwards as well. And I learned so much throughout the course of this project, and this is something I also strongly recommend to you. Just try out different technologies and different approaches and learn with it. You will not learn unless you try. As I told you in the very beginning, one very important ingredient for becoming a smart home guru is to try out always new technologies, new approaches, and to just experiment with your smart home. So, I will tell you a little bit more about my project so that you can see how I developed into a smart home guru as I am today. But before that, please take a second to subscribe to my channel in order to get notified also about all of my upcoming videos. Thank you! Let's dive into one other project, which was the automated parcel receiver. The motivation for this comes from the time where the parcel delivery service would always bring your parcel to the next parcel shop when they didn't find you at home. In our case, this parcel shop was a 10-minute drive away. But even worse, the problem was that the opening times were so bad that you just couldn't go there during the week. And on the weekend, on a Saturday, you had to stand there in line and wait for a very long time. And I can definitely tell you that I have better ideas for how to spend my Saturdays. So I started to think about how I can solve this. My idea was quite simple. I usually receive shipment announcements some days before a shipment will arrive at my home. Those shipment announcements via email contain the shipment IDs. Those shipment IDs should be the same as on the actual parcel label in the barcode. So I realized if I could store the shipment IDs that are announced in a database and then check them against the shipment IDs in the barcodes of the actual parcels, I could verify if a parcel is actually for me. And if that's the case, I could just open the garage door so that the parcel delivery service could just drop the package in the garage. Wouldn't that be a nice solution? I started implementing the most simple part, and that is the email parcel. I just implemented a script that is running through my emails every night, checks the emails for shipment announcements, and if there is a shipment announcement, it parses it and extracts the shipment ID in order to store it in a database. Then I implemented the possibility to open or close my garage door. My garage door comes from Chamberlain, and they have a solution that's called MyQ. Back at the time when I implemented this automated parcel receiver service, it was still possible to access their API in order to control the garage door. There was a library which was called PyMyQ, which I was able to just integrate into my Python script in order to open or close the garage door. Worked flawlessly. Now the complex part started. I needed to find a solution to scan the barcode on the shipments that will be brought by the parcel delivery service. This scanner needed to be outdoors, so it needed to be kind of weatherproof, and it needed to have a very high quality of recognizing the barcodes. After thinking a while, I came to the idea to use my video intercom system for this. It's an analog video intercom system that was already pre-built into my house when we bought it. It's not of high quality, but it has a camera outside and this camera is weatherproof. So if it would be possible to get the picture from this camera into my Python script, I would be able to parse the barcodes in the picture if the parcel delivery service just holds the package in front of the camera. I just needed to find a way to grab the video signal of this analog video intercom system. I took one of the video monitors for this video intercom system, which are installed in my house from the wall, and I saw that there is a cable for the video input. So I bought a USB video grabber device as well as a 2.4 MHz video sender, which allows me to send the signal from the cable behind the monitor in the wall to a Raspberry Pi somewhere in my house. And it worked! I was able to receive the video signal from the analog video intercom system on the Raspberry Pi, and with that I was able to parse the different video frames with OpenCV to identify the barcode in the picture, read out the number that's encoded in the barcode, which is the shipment ID, compare the shipment ID to the shipment IDs that were stored in my local database, and in case there is a match, open the garage door. The parcel delivery service would then have to drop the package in the garage and then push a button inside the garage so that the garage would close again after 1 minute or so. And then I would also receive an automated notification on my smartphone so that I know there is a new shipment dropped in my garage. But unfortunately, the camera belonging to this analog video intercom system was of such bad quality that in most cases, unfortunately, the recognition of the barcodes just didn't work. If there was a bad contrast and there was not so much light, it was even worse. So I kind of got this project running, but I never really got it productive, because when I thought about how could I improve the quality of this camera or the quality of the barcode recognition, COVID came. And you know, with COVID, all the problems were solved, because since then, up until today, the parcel delivery service just drops the packages on our porch, so there is no problem anymore. But even if I never really got this project productive, I learned so much from it. And there are so many more projects that I worked on since then in my smart home. I'm really a smart home guru. Now you know nearly all of the ingredients for becoming a smart home guru, and you also know how to get there. But remember, at the very beginning of the video I told you there is one more very important ingredient for becoming a smart home guru. Now I will tell you what this is. It is the family acceptance factor. What does it mean? Whenever you design a smart home solution, you need to make sure that you have the acceptance of all of your household members. Because if you don't have the household acceptance, this will be probably your last project that you're allowed to work on. If you build a smart home solution for your household, make sure that you really consider all requirements of all your household members. In my household, there is one person who always wants to be able to control everything the classic way as well. So I need to make sure that whatever I automate, it's still possible to do it as usual in the classic way. If I do that, I have the acceptance. And this is very important for you. If you want to become a smart home guru, please make sure to really consider the requirements of all of your household members. Thank you very much for listening. And just watch these other videos here, which are really showing you much more of my smart home project.